Let's see if I can plug in my controller without it. OBS getting all confused about having a new microphone or headphone source to pull from. Didn't do that for the Xbox controller, to be fair, but this is a different one. Also, will Unity pick it up? I assume it will, but you never know, really. It should, right? But these PS4 controllers are compatible. Yes, it does. Okay, that's good. So, yeah, everything works basically exactly as it did before. I did make some adjustments, some minor adjustments to how the camera works. Now it doesn't go all the way up when you push the stick only a little, it only goes a little bit up, and the same for down. If you push it only a little bit down, it'll only zoom in a little bit. This makes it so that you can turn to the sides without the camera going oh woo immediately, you know? And for mouse controls, also a couple of adjustments. Now the game, when you detects that you're using mouse, it keeps track of how far up and how far down you have the camera. This is so that when you release, when you stop moving, right? Because the input is the delta of the mouse. That means that it only detects mouse movement, not mouse position. This makes sense because I want to lock the mouse to be in the middle of the screen, but that makes it so that if I stop moving the mouse up, it detects an input of 0 and then goes right back to normal. And that's not what I want. I want it so that if you move the mouse down, you're now looking down. And so that's the way it works. But that's only the way it works for mouse, because for joystick, you know, if you release the joystick, you go back to normal position. You know, those just feel like more comfortable options. So now what we are going to do today, hopefully, is get started on a bit of what is the main gimmick of the Haynex, on what is going to be the gimmick of this game, which is a bit of a rhythm element. Now, in order to do that properly, I'm going to need a couple of things that I think that I can pull up from previous project. That is a script for music management that actually I was pretty proud of. It made things very easy. It basically made it so that each scene had assigned background music, and so it would stay alive throughout scenes and keep track of when to play each music, right? It also made, like, the cool thing about it was that I could put one of it in every scene, and they would make sure to kill themselves when they detected that another one was still alive. And this worked wonders for the purpose of um, being able to start from any scene and still have music play, right? That was the whole thing. So if I can just grab that script and copy it into this, then I should be good for managing background music. But first, I need some actual tracks that I can test the gimmick for. After all, it is a rhythm game-ish, rhythm platformer sort of thing. Why do I have two Cinema Machine virtual cameras? What's going on? Oh, this is the backup. Yeah, I don't need this anymore. Yeah. Okay. So, first things first, I'm gonna need to make a bit of a background track that I can use. It has to be something very... And I haven't thought about how I'm going to do that, actually. Like, I guess I could go into MuseScore and just put a BPM in there and do thing. But can I export that to like an MP3, like a WAV file with just the shittiest MIDI? I can probably download something with a just a metronome. Oop, don't go away. I can probably just download like a metronome sound. Mm. Huh. I should have thought about that before I did this. Well, let's start by copying that script, actually. It would probably be better to like download. Why do you open every window on the second monitor, you bitch? Holy shit. Yeah, so I have to find that. I think it was on my Unity folder. And it would be this one. In assets, surely. We have a lot of scripts. Binary player event, enemy, that is probably event. Event timed event, trigger event. Camera controls, change sort on destroy and load, need prog, toggle active. Animation message, animation target, change angle, color switch, print direction, sprint when interact on grave. Character indexer and dialogue writer, chase and life. Any light event, collision event, disable event. Disable and escape, input manager, interact event, light hit events, lights event, pulse handler, scene loader. Might have been the scene loader. It wasn't the scene loader. Okay, timed event, trigger event, trigger event again. Oh, why is it twice? Oh, trigger event int. Okay. The player's animation control, copy rotation, flashlight control, interact, and player movement, so none of those. Scenery? Global light control on wall? No, that's not them. That's not them. Camera control, camera trigger, change sort. Don't destroy, unload. That's probably the one. That's a terrible name. Yep, this is the one. This is the one. Because it has the music and everything. Okay, I'm just gonna need to change the name of this script and I close the fucking... It's not showing what you're doing, I don't think. No, it is. It is. It's just not showing me browsing through my folders because I don't want you to see my whole fucking folder structure. Yeah, that's what I was doing. I was reading them out loud. Okay, so I want to grab that script and copy it into my actual current project. What was it called on Destroy and Load? Yeah, I'm gonna have to change that name. That's a terrible name. But for now, we just copy it. Scripts. Don't destroy, unload, copy it. Go back to the current project. And we are going to put this into a folder that's gonna be called Scene Manager. Probably, right? We're just gonna call it Manager. Managers. I'm gonna have this doesn't destroy and load. Then we are going to close this. We're going to open this new copied version of it. We're going to change the name on it to something else, something that makes more sense. So this is going to be the Music Manager. And we are going to rename the script to be exactly that. So come here, rename this to Music Manager. And then we go back into Unity. And that should give us what we want. Yes, a meta file has appeared. A new folder is here. Okay, there we go. Alright, that's exactly what we want. So, why did you become small? Why did you open? What the hell? Oh, it's because you opened another window. Okay, well, that's weird. Don't worry about it. Okay. So, these cubes, I'm going to put all of these cubes and the floor are going to all go into an empty game object because so that this whole structure is a bit more tidy. Then we have the Cinemachine virtual camera that goes right here, and the actual camera that is currently being controlled by the Cinemachine thing. We have the player. We probably should save most of this new stuff. And okay, so we're set for trying. So now we have this terrain. We want... Should the camera be our manager? No, we should probably just have a new object that is our music manager. So let's do that. Alright, so in order to do that, I would have to have a new game object. This is going to be our music manager. And this is going to have two components, and one of them is going to have to be an audio source. So I'm going to need an audio file that has a known BPM. Where the fuck do I find that? I mean, anything will work, right? It's just for testing this. Oh, I know where I get it from. Where to get it from. No, actually, that's a bad idea, and I shouldn't do that. I don't have any music files. I do have the one that I'm using for stream. Do I know the BPM of that? Can I find that out? It's Professor Layton, The Curious Village Puzzle OST. If I can find the BPM of this little track easily. Professor Layton OST Puzzle BPM. Nope. Not. It's not like an easy answer. Okay, so I'm gonna need to think of something else. Just find a YouTube video of a metronome going at a steady, I don't know, 220 BPM. And just download that file. Okay. I wonder if you can hear that. Oh no, because I have my desktop audio turned off. Well, it's fine. I just have a YouTube video for metronome going at 220 BPM, and I'm just gonna download that as an MP3. That's gonna be our thing. It would be nice to use some actual music, but this is probably easier for testing. I've done this before I started streaming, honestly. Okay, is this what we want? Yes, it is. Okay. I can hear it. You can't. And I'm gonna have to fix that, but that's gonna be for as soon as I put it into Unity. Right now, it doesn't matter. So let's see. Let's put this here in a resources folder, because that shouldn't be uploaded to the... Why did I make it a script? 'Cause that's not gonna be uploaded. Having this fucking script. Yes, delete it. Yeah, because that folder is not going to get uploaded into GitHub. And last time I uploaded resources into GitHub, it took like fucking 10 minutes to download with the fucking slow ass Institute internet, so I'm not doing that again. Rename to resources. Let's actually properly double check that that's not gonna be... No, you are. Well, just the folder, surely, right? Not the contents of the folder. Oh, it sure is taking you by a bit. Unity, make sure to not explode, yeah? Okay. So GitHub, are you putting that in? No. Okay, so it's just taking care of the folder. It's not even actually putting in the folder. It's just... Okay, well, just the meta information for the folder. Okay, so we have this metronome thing now. So what I wonder if you can hear it on stream. No, but it's gonna make noise here. Actually, my voice is going to come through twice if I do this. One second. Actually, next, are you still there, Steven? Can you tell me if like there's an echo? Oh, there's not only an echo, you can actually hear the fucking BGM, Jesus. Yeah, that's not good. Can I make this its own lone audio source? No echo currently, okay. Can I make this its own audio source? Like, media source, audio output capture. Audio output capture is just Unity audio. And like here, say the device. No, this is the device. No, I don't want to do a device. I want to do a. I want to do like an output. Ah, come on. Oh, I remember how I used to do this. I used to have fucking voice meter. Echo? There's an echo now? You have like 30 seconds of delay actually. This is probably not the missing thing to ask. Like you probably, yeah. That makes sense. Okay, how would I do this? I would have to make Unity output to a different device and then make OBS listen to that device, or get fucking voice meter. The problem is that I haven't gotten that fucking thing in a while, so I have forgotten how that works. Or I could just say, fuck you, you don't get to listen to the metronome. But that feels a bit shitty considering that that's what I'm gonna be working with. Whatever, I'm just gonna fix that for next stream. For right now, it's just... You'll have to deal with that. And just trust me that when I hit click play, you can hear like a tick, 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 tick sound. You know? Okay, so what do we do now then? Well, this music manager needs the music manager script. Which is this? It has a right. It assigns a scene to a audio clip. So right now we want there to be this scene that we're on right now, which is called test scene do not touch, and the audio source is my 220 BPM metronome. So when I click play, I should be able to hear that metronome. Tag music one is not defined, right, because this works by taking advantage of tags. This is not the usual tags. What the hell? Add a tag. Music one. Music one. No, it's music space one. Oh, fuck's sake. Okay. Music space one. There you go. And that is the tag that you are going to have. And that should do it. Right. So a couple of weird stuff has happened. First of all, the music is not happening. Second though, the camera is all the way zoomed in, and I'm not touching anything. When I move the mouse outwards a little bit, it works, but then as soon as I move the control, so it seems to think that this is its default position. Why? Have I moved the camera by accident? No, this is its neutral position and it is what it should be. What if I start it again? Everything going well. Move the camera up, move the camera down, release. Ooh, okay, so I might have uncovered a bit of a bug. Nope, I can't recreate it, so it's not what I thought it was. Okay, well, we'll just assume that it's a really rare thing, that it's not going to be an issue until it happens again. Okay, in that case... Okay, so why is the sound not happening? Why aren't I hearing my metronome? Let's go dive back into the script and see what it actually does. Again, you keep doing this, Visual Studio Code, and I don't want this to be open. I want this to be tiny and non-existent. Let's see. I have a serializable thing that is a scene music type of thing that has a name, which is the name of the scene, and a music track, which is an audio clip type thing. I have it set so that I can set as many of these as I want in an array, and I have an audio source thing. So, what do you do? So, what you do is when you awake, you tell this object to not destroy your load. This makes it so that if I change from one scene to another, this one won't get unloaded like every other object in the scene. Then it's going to find objects with the tag music1, which is only this one. And if it finds one, it destroys itself. That means that only the one with the No, it destroys... Wait, it destroys itself? Oh yeah, that means that I only have to load it once, but it doesn't matter if I have to load it at the same time because they will destroy each other. It will only destroy the one. Wait, is that how it works? Right, that's how it works. That should be how it works. Okay, so then you start once it loaded. Yeah, you just right. And oh, this happens after a scene has loaded. Oh, hold on. This is for handling player preferences. This has nothing to do with any of this. And then for an int from 0 to scene's point length. Okay, yeah, but this is only going to be happening every time you load a scene, which means that you have to be set beforehand with the music, which is why probably I made this audio source a public variable instead of just leaving it private and leaving the list of scenes to handle that. So that means that I have to drag this here. This means that I have to drag this here. This means that I have to drag this. Oh, audio source is a type of component, not a... Yeah, that makes sense. Okay. Not a type of asset. Okay, so then I want you to have volume, pitch, whatever, loop. Definitely. Okay, so now we have it. Right, okay, so now I'm hearing the metronome. Okay, so that's a good start. What do I want to do from there? Well, first of all, we need a script or a structure or something that can hold the BPM of the song, of the current song, into a variable that we can check. Now, given that this is already handling the different musics, I think that it wouldn't be, you know, a bad thing if this also was the one that knew the BPM of every single track. At least that seems to make sense to me. So then, all I have to do is add to each of these pairs a third variable that says if this is the music, this is the BPM we're working with, and that has to be an int. No, it has to be a float because sometimes you get odd BPMs. Yeah. Yeah, let's make it a float. So then this gets a public float type variable that is called BPM in lowercase. And then this should be BPM in uppercase so that I can assign the actual BPM in lowercase. So then you, the builder, get also a float BPM, and then I get to say this code I don't exactly understand, but like I know that it makes the thing work. Yeah. And then I can set the BPM here to 220. So now all that we have is we have stored a number and associated with that music track. And now what we want to do is actually use that number. 220 beats per minute means 220 divided by 60 will give us beats per second, right? Beats per minute is beats over minute divided by 60 because 60 is 60 seconds per minute. So that will be minutes squared. No, it has to be the other way around. No, yeah, it is because we divided. So instead of being seconds per minute, it's minutes per second. So then the minutes cancels out, and then we have beats per second. So 220 divided by 60, how much is that? Let's see, where's my calculator? Here we go. So 220 divided by 60, that is going to be a total of 3.2 thirds. 3 and 2 thirds beats per second, which means that 3 and 2 thirds beats per second. Which means that 1 over 3 and 2 thirds, or that is to say the reciprocal of this, that's the number I want. It's 0.272727. Repeating is the total time in between beats, less than a third of a second. So let's just test that real quick. Let's say that one of these cubes is going to have a little debug script, right? This is just to test if my math is correct. So act on BPM. I'm gonna uppercase the A. Right, act on BPM. So what this is going to do is this is going to have a event. I think that's how I write them. Let's see. Yeah, you have events, so show me. Yeah, it's events. And then from here, this is going to have a float variable that is a BPM. What's going on? Oh, this is what's going on. Okay. That is the BPM that we get to set. And then what this is going to do is on update, it is going to... We also need a timer. Private timer. It's a float. So then an update, what this is going to do is it is going to take this timer. Right, first of all, we gotta do something to set the timer up at the start. Void start. So first of all, we have to calculate that number, the delay in seconds rather than in beats per minute. Obviously, it's going to be way easier for me to go off on beats per minute when it comes to actually writing the things out. So I want to have a function that does that on its own. So returns a float, and it's called BPM to seconds. Sure, that's explainable. So this receives a float, and it is the BPM. Also, we're gonna call this BPM in lowercase. And so, what you do is you take this BPM, you divide it by 60. BPM divided by 60. Yeah, we have to return this. BPM divided by 60. Okay, so let's get this straight. BPM is beats per minute. Dividing it by 60 is the same as multiplying by 1/60th. That is 1/60th minutes per second. Every second is 1/60th of a minute. So that is minutes per second. So that is minutes and minutes will cancel out, and then we have beats per second. And then we want the delay. So instead of beats per second, we want seconds per beat. That is how many seconds in between each beat. So then we have to divide it by, 1 divided by all this. So the reciprocal, so to the minus 1. To the power of minus 1 will give us seconds per beat. So then So then what we need is the reciprocal of this. That is just 1 divided by the result of the BPM divided by 60. And then yeah, we wrap all this in this. Yeah, like that. So then now what I want to do is take a float that is the interval, and we're going to calculate that interval. So interval is equal to the conversion in BPMs to seconds of the BPM that was inputted before BPM. And then the timer must be set to be equal to that interval, right? So now we have a timer. So the idea of storing the interval is that then we have to reset the timer to that interval whenever we run out of time. So then each frame, the timer is going to be equal to itself minus the time that has passed is the last frame, delta time. Then if this timer is below 0, then that means that we have run out of time. So in that case, what we have to do is first of all call this event, which is what we have to do here. So yeah, unity event type, it's a public, and this is on beat. So then we have to call that event. So on beat, if there is anything on it, it will happen. We will invoke it. Do we do that with a parenthesis, or I always forget? Yes, you do. Okay, you invoke it, and then we have to reset the timer. So the timer is going to be equal to the interval, but here's where we have to be careful. We have to subtract from it what the timer already had. This means that if the timer was, instead of being at 0, it's very rarely going to land 0. If we set it back to the timer, then it's going to ignore by how much we overshoot, which means that over time it's going to go out of sync. What we have to do is reset it and take into account how much time has passed since the beat. So that is just subtracting from the interval the timer. And there we go. Right. Right, I didn't do anything with that script, so that's not gonna no reason to test. So then what I want to do is grab this cube, right? This cube is going to have this act on BPM thing. Well, this act on BPM, we're gonna tell it that the BPM is 220, so it matches the background music, the BPM. And then what we want to do is let's take this cube and tell it to act upon this other cube. And what we're going to do is right, we want something that we can edit, so yeah, let's make a script that just moves it a little bit, so just so that we can see. Move to position. We're going to make another folder so that we can put both of those scripts as debug scripts, because they are not going to be used in the actual game. The only purpose of them is for me to be able to test stuff, and so I don't want them to clutter debug scripts. The act on BPM might actually be useful, but we'll see about that. So then, move to position. Okay, so now I want to do a thing. You are to have two positions, which is position. Yeah, we want a public vector 3 type called position 1, Then another one that's the same, but it's called position. And so we want that whenever this function, this new function that I'm going to create gets called, so public move, let's call it move to, move to. Whenever this function gets called, you're going to check if you're at position 1. If you're not, move to position 2, etc. So if transform point position equals position 1, then transform point position is going to be made to equal position 2. Otherwise, it's going to be made to equal position 1. Right? Yeah, just as easy as it could be. Oh, method must have a return type. Okay, I guess I forgot that. This is returns nothing. It's a void. Also, you don't exist anymore. Not in that position anyway. Oh, hi! Guess what I'm working on? Right, so I want to... Right, so who did I put that thing on? I didn't put it on anybody. Okay, so you move to 2 positions. These positions are going to be fucking, let's say, 0, 0, 0. Where does that end up? Right here, okay. So we want to move you to 1. We want to move you to 2. That is going to be your starting position, so that's going to be 2, 0, 0. And you're going to move to... Oh. Yeah, you do that. That way I don't have to do it. That would be great. Right, and this end position we want to be 2, 3, 0. So now we should actually see blink in time with the beat. It's not doing shit, right? Because I forgot to tell this guy to actually send that message. So... Which cube is it? It's cube 6. Okay, cube 6. Yeah, move the position and make it move 2. Okay. You can't hear the metronome, but like, I'll be able to know if it's going to the beat. What happens if I move under it? It doesn't seem to go out of alignment if I wait a bunch, so that's a good sign. Although if it did go out of alignment, honestly, I wouldn't even be sure if that is just, you know, the... whatchamacallit, the video that I got just not being exactly 220 beats per minute. So, yeah. Okay, so this works, right? That's extremely good. So, what I need now is actually to figure out how I'm going to handle the whatchamacallit, the actual mechanics of this shit. Let me see. Okay, those scripts are promising. I'm just gonna take them out so that we can work on this. Right. Okay. So now what? I guess the player at this point would need a canvas so that it can show things on screen, because that's the first thing that needs to happen. It needs to be that when I press the jump button, it shows a little graphic that will tell you when to press the other stuff. Then after that, I need to line up those things. Fucking, I hate lining up menu UI elements. Just I can never seem to get it right. Not Q, never Q. Then after that, I'm gonna need to actually make it so that the character can act. Yeah, okay. This sounds like it's going to be some work. Let's start by adding. Okay, hold on. Actually, think. The main problem with this is that right now the things move to the beat, they react to the beat, but they're not exactly on beat. They're just at the same timing as the beat. So if you're half beat off all the time, the cube was moving half beat off of, like, it was moving off beat. It was on time, but it was off beat, right? And that's what we decided that we didn't want to do. So then what I actually want is to make sure that this can line itself up with the beat. So in order to do that, I need to be aware of where exactly on the play on the audio source we are, like how far along, which sample of it, right? The problem is that this kind of depends on sampling rate, doesn't it? Actually, I need to read up on that. So audio source, right? If there's a variable in there that I can read that will tell me which sample we're currently reading at this moment in this particular frame, then that is going to help me. Audio source. Well, that means that every track is going to need its own delay, right? So that's fine. That shouldn't be. That's just trial and error, isn't it? Let's see here. This is the Unity documentation. Shut up. A representation of audio sources in 3D. An audio source is attached to a game object for playing back sounds in a 3D environment. In order to play 3D sounds, you also need an audio listener. The audio listener is normally attached to the camera you want to use. Whether sounds are played in 3D or 2D is determined by audio importer setting. You can play a single audio clip using play, pause, and stop. You can also adjust its volume while playing using the volume property, or seek using time. Multiple sounds can be played on the audio source using play one shot. You can play a clip at a static position in 3D space using play clip at point. See also audio listener, audio clip, and audio source component. Audio source component, surely. Oh no, this is just not the scripting version of that page. Okay. Bypass effects, no clue. Bypass listener effects, bypass reverb sounds, clip, which is this. Doppler level? I didn't know we had that. Gamepad speaker output type. Ignore listener pause. Ignore listener volume. Is playing. Is virtual. Loop. Max distance, min distance. Okay, hold on. I'm realizing something. The audio source is in this invisible music manager thing. That means that if the player moves away from it, we may stop hearing the audio. And by we, I mean me, because I haven't set it up for the stream. So let's check that. I can still hear it loud as ever, but maybe I'm just not far enough. Let's just let myself fall here. I have killed him. Her, him, her, them. I have killed them. Okay, so I can still hear the audio. That doesn't seem to be a problem, but why is this then? Why is this whole thing here then? To begin with, where is the audio listener? It's on the main camera, and the main camera moves with the camera, so that shouldn't be... Like, you saw the listener, right? Like, over here, hold on, like, over here, you saw it move from here to here, so, like, it seems to me like it should have, is it because of the spatial blend? That would make sense. Oh, okay. So setting it to 2D just makes it basically not matter. Actually, I should read what spatial blend actually does. Spatial blend sets how much this audio source is affected by 3D spatialization calculations. 0 makes the sound full 2D, 1 makes it full 3D. Okay, but what does it mean for it to be full 2D? Aside from determining this property is useful to morph between the two modes. 3D spatial calculations are applied after stereo panning is determined and can be used in conjunction with pan stereo. Morphing between the two modes is useful for sounds that should progressively be heard as normal 2D sounds the closer they are to the listener. That's how much this audio source is affected. Okay, what do you mean 2D? What does 2D sound even mean? You can probably tell me. Spatial blend, that's what I'm looking for. Spatial blend. That's how much the 3D engine has an effect on the audio source. So 2D just means no effect. It doesn't mean like a 2D effect. It just means no effect. That's a weird way to put it. Why would you call it 2D? Like, it's not like distances don't exist in 2D. That's fucking Unity, I swear to God. Okay, so then I just want this to be 2D because it's global, right? I just gotta make sure that this remains at 0. Okay. Then, don't. Right. Okay. So, that's not what I came here for. I just needed to know what that setting did. What I actually want is spatial blend, specialize, post effects, spread, time, playback, time in seconds? In BCM samples. Are seconds less precise? Because if they're not, no, it is more precise. Okay, so I definitely want to be using samples. Be aware that on a compressed audio track, position does not necessarily reflect the actual time in the track. Compressed audio is represented as a set of so-called packets. The length of the packet depends on the compression settings and can be quite often 2 to 3 seconds per packet. So I definitely don't want to use seconds. I definitely want to use time samples. Okay, the problem is that I'm going to need to know exactly at what sample a beat is happening. Once I have just one beat precisely located, the others are fine because all I need to calculate the others are the BPM of the song. But I need to somehow find, okay, what's a PCM sample? Because if it is what I think it is, I may be able to just go into Unity, not Unity, into Audacity and find it out there. Pulse code modulation is a method used to digitally represent sampled analog signals. It is the standard form of digital audio in computers, CDs, digital telephony, and other digital audio applications. In a PCM stream, the amplitude of the analog signal is sampled at uniform intervals, and each sample is quantized to the nearest value within a range of digital steps. Linear pulse code modulation is a specific type of PCM in which the quantization levels are linearly uniform. This is in contrast to PCM encodings in which quantization levels vary as a function of amplitude, as with the A-law algorithm or the mu-law algorithm. So PCM is a more general term. It is often used to describe data encoded as LPC. A PCM stream has two basic properties that determine the stream's fidelity to the original analog signal. The sampling rate, which is the number of times per second that samples are taken, and the bit depth, which determines the number of possible digital values that can be used to represent each sample. Yeah, so bit depth is basically audio quality, in a sense, and the sampling rate is something else. Okay, so if this works the way I think it does, then I should be able to just go into Audacity, and I have it in a different folder than I thought it did. Here it is. Okay, yes, I know. Don't install the update, please. I could just get it later. Okay. I can go into Audacity. I can grab my file. This one. Oh, show in Explorer. I can make a copy. No, no. We're not making a copy, not yet. So I can put this file in here. I can put this file in here. And now right? Can you even hear that actually? That might have been a bit too loud, sorry. Okay. There's probably an echo actually. Hold on, let me... Okay. Right, so... yeah. It should be gone now. So, what I want to do is... This is 30 minutes. What needs 30 minutes of metronome? Fucking hell. Make it shorter. Make it 2 minutes. Jesus. What the fuck? That explains why this looks so tense. Right. Why do they seem to get louder? It's probably just an optical effect from the way that it displays this. Okay. So, in that case. So here's what I want to do. Just to make sure that I can actually find a sample with precise timing, I'm going to make just a shitty little thing here. So I want to find, for example, let's zoom in more. Okay, so I want to find this specific beat. In order to be able to find it, I'm gonna just do... no, you're recording at the end, you fucking MILF. I don't want you to record at the end. I want you to record at the fucking... the place where I had it at. I need to make another track for that. Okay, so let's say that I want to find this specific beat. I need a new track, be stereo. And what the fuck did you fucking cunt? Record to the empty track. Obviously. I mean, yeah, that's what I do. I get mad at inanimate things. That's like one of my many things. Ah. Okay. So what I want is to find the specific beat where actually the one immediately previous. That's how I'll know that I got the right one. Because if I have one of these ones in the middle, then that's kind of indistinguishable. So I want to find the beat immediately previous to this scream. It's not really a scream. To me saying the noise. So it should sound like that when I play it in Unity. So first of all, I have to take this, export it as a wave. It has to be a wave because it cannot be compressed. Let's put this just on my desktop. And then I'll put it in Unity. Yes, I know, thank you. I know how exporting shit works. And then go into Unity. And, well, now that I know that this thing is half an hour long, I can't keep it like it is, but I'll take care of that later. And it has the exact same fucking name. Okay, now this is a new one. 220 BPM test. Right. So what I'm hoping is that the samples that Audacity will show me are the same as the samples that Unity will report with that one variable that we saw. So what I want to do is kind of find there's no need to be that precise, but kind of find this sample and see where Audacity can tell me the number of this sample. Now, I think there's a way to do that, but I have no idea where it is. Probably view, track size, skip to, history, mixer toolbars, show clipping, select all known regions, spectral audio clips, edit, copy, paste, duplicate, remove special labels, labeled audio metadata, preferences, file, transport, cursor to, transport options, looping, cursor to scrubbing, recording, playing track, generate, effect, no, definitely not effect, sample data export, sample data import, regular interval labels, no, quick help, diagnose, okay, so, okay, I'm gonna have to Google this one. Audacity, current sample, cursor sample. The extra cursor menu provides commands for moving either the editing cursor, playback cursor, or an audio tracker clip. Okay. Is this a new thing? Because I really can't see it. Oh, it's on right click. Okay. Minutes and seconds, beats and measures. Beats and measures? No. Loop button off, clear loop set, loop pinned, minutes and seconds. Okay, that doesn't help me. Extra. There's no extra menu. Nope. The problem is that there's many things that are called samples or that have the word sample in them, so it's difficult to Google this. Free Audacity loop samples, mouse preferences. Audacity current sample, how to find out. Sample rate and bit depth. That doesn't help me, but it's close. File open, written file, save project. I know that there's a way because I did it once long ago. Save project, close, edit, cut, delete, remove special, audio clips, labels, label to audio, metadata, maybe preferences. Project sample rate, default sample format, buffer length, okay. Playback, recording, mid device quality, interface, language, theme, meter, decibel range, extra menus, beep, completion of longer activities, retain labels if selection snaps to label, blend system audacity theme, use mostly left to right layouts, dialing tooltips, stroke ruler. Select all audio if selection required, enable cut lines, enable dragging, editing a clip, can move, drag, focus, type to create a label, use dialog for the name of a new label, anywhere scrolling left to 0, advanced vertical zooming, smart clip, no, spectrograms, not what I want, extended libraries, directories, warning effects, keyboard, mouse modules. Density sample number. Selection and number of samples. That's promising. Change the display format in the selection toolbar normally at the bottom of the window. Change the display format to samples. So this? But where though? Oh. Oh, that helps. Okay, seconds, second per minute, seconds, hour, minutes, seconds, dates, hours, minutes, samples. There you go. Right. Okay, so this is sample number 1,456,557. So then what I want to do is let's copy that number and paste it somewhere. Actually, I can go back to it. Okay. So what I want to do is go to Unity and I want to go to this guy, the music manager, and I want to give it this other file, the test one, the one that has my beautiful voice on it. And I want this music manager script. No, not the music manager script. No, because this is just another thing to test stuff on. So we're going to create a new debug script, and this is going to be move to sample. And this is going to have, first of all, it's going to have an int, public int. This is the sample that we want to move to, so sample. Right, second of all, it's going to have the music component, the audio source component. So audio source component, where the fuck is that? It should be in the music manager script, probably. Audio source component, yeah, there it is. Okay. Audio source, right? Then it is going to take this audio source component, and when I press a specific key, fuck it, this is just a test script anyway, so we're gonna make it so that when it is enabled, on enable, So when this thing is enabled, you are going to take this audio source component. You are going to, I closed the fucking browser. Audio source, there it is. We're going to take this audio source component. You are going to pitch, roll off, specialize, spread time samples. Okay. To read or to seek to a new playback time samples. Okay. So when you enable this, you're going to take the audio source point time samples, except this is this name instead of that one. And you're going to make it equal to the sample that we have set as the thing. And then that should be it. So then what we do in order to test that is we are going to need to create, well, first of all, that thing compile. And we're going to need to create a empty, and this is going to be the manager manipulator. I mean, it doesn't matter because this is going to get deleted as soon as I get the confirmation that this works the way that I want it to. Then we're going to give the script to move to a sample. Then we're going to give it sample number 1 mil. I'm going to type it in chat. 1,456,557. Then this is the sample that we want to move to right here, and the audio source that we want to move to that sample is this one. And so whenever this object is enabled, it's going to grab the sound on the background and move it back to that sample, which should be 1 beat before I start making the noise. So okay, so let's delete this. So what this means then is that I can reliably get from this number to the global number, which means that I can, by putting it into Audacity and then remember where the first beat is, calculate where every single other beat is going to be purely with the BPM. So that's good. So let's actually test that. So what we want to do then is to grab this music manager, and now each scene is going to have the name of the scene, the music that plays in that scene, the BPM of that track, and a beat. Oh, hold on, it's going to need the sample rate as well, because otherwise I can't calculate it. Will I need the sample rate? Can it get the sample rate? Can I get the sample rate just from the audio source component, or from the clip itself? Sample roll-off, specialize, spread time sample. Okay, if it's anything, it should be on the audio source, on the source clip, which is a type of audio clip. So it should be in the audio clip, if anything. Ambisonic, channels, frequency, length, loading background, or frequency, sample frequency of the clip in hertz. The sample frequency. Okay, is this what I want? That doesn't help me. But it should be, right? Right. The length of the audio clip in samples and the sample frequency. Okay, so that means that I can get how many samples per second. The problem is I'm going to have to remember what hertz means, what unit that is in, but that's, I mean, the unit is hertz, but what does hertz mean in, you know, in seconds, samples per second? But that's fine. I think it's just samples per second, or rather, waves per second. I forget what the actual term is, but that's fine. It doesn't matter. Okay. So then that means that you are going to need, on top of that, this already has the information for the sample rate. So I can go to here, and I can seek in Audacity what the first on-beat sample is, right? It's a bit difficult to see here though. So let's zoom out. Okay, it's right here. So let's say that it starts here. This is the sample that we want, this one. So this is sample 3467. That's a lot. Right, 3467. I'll write that here. 3467. Right? And so if I go here, then to the music manager, then each one is going to also have a float. No, an int. That is going to be the first beat. That is the sample on which the first beat lands. So then we can add it here. So int first beat, and this is going to be in uppercase to match the other variable names. And then we assign it right here. First beat equals first beat. And so we go to the actual thing, let it compile. We tell it that for this first thing, the first beat lands on 3467. That's the sample. So then what do I do with that number? That's the thing. I have to say that right, what do I do with that? Right, what do I do with that number? That's not quite as easy, is it? Right, because I need to check with the music, with the not the audio clip, with the audio source component. I have to check which sample you're currently playing, and if that sample is at or above, yeah, so it's going to need variables that keep track of when was the last beat played, because yeah, that's what it's going to need. Audio source point time equals 0, audio source point play, audio source point clip scenes I point music. And then break from it because we don't want to check anymore, but we also need to set up a couple of other things. So the right, hold on, give me a second. Okay, now the music is back. Okay, so what I want in that case is to we should have variables stored for what the current BPM is, and the first beat doesn't matter because that's just no, the first beat does matter actually. So for what the current ones are, like these are the ones that are cumulative throughout the whole game. So they will have like the entire library of the possible music tracks. but we are going to need to have them individually. Now the question is, do I want them to happen on this script, or do I want a different script that handles the BPM calculations based on what's in here? And if so, how to handle giving that information to that script? Because it feels like it could get messy really quick if I do it in this one. So... Oh. Because this is going to be constantly running timers, isn't it? I guess it makes sense if the music manager is the one handling all that stuff, so... Yeah, I'm just gonna have that. I'm just gonna have that be the case. So... But we're going to need to comment this code a little bit better so that I have stuff handled. So first of all, we're going to have a header here. It's just going to be music library. We're going to have another header here that is just references. This is just to have it be a bit more tidy in the inspector. And then another header here that is just variables. And then these are the variables that are just timings and such to have to keep in mind. Then I have to remember that this is changing the music to match current scene. And then this is just killing duplicates. That is what these pieces of code are doing. I also have to make sure that when I kill the object, I unsubscribe this function from there. But I'm not sure if that's going to break things. In any case, it just at the very least means that I'm not carrying garbage data. So let's just put this here tentatively, and if it breaks something, we take it out, and we'll have to remember that we did that. So let's put a comment here. Not sure if this line breaks anything. And then scene loader. Scene loaded. Unsubscribe the on scene loaded function. Right. So then. So. What do I want to happen from here? Next, I want some... well, next I want to go to the bathroom, actually, so give me a second. Nope, that's the wrong text. This is the text I want. There you go. Alright, we're back. Right, back at it again. Right, so what's going to need to happen for this is that this script is going to have to be checking every single frame for which sample we are on. That should not be an expensive thing to do, but you never know, really. So, let's make that void update. It needs to happen every frame. Actually, does it need to happen every frame, or does it need to happen in every fixed update? Because if it happens in update, fixed update, basically the question is, should the beat be checked every frame or every physics cycle? I feel like I want it to be on a physics cycle because gameplay elements are going to be dependent on this. So if a beat happens twice while the frames are hanging, the effects of it need to happen twice. And so you need to check it every physics frame, yeah. It just should be in fixed update. Now we're still going to, now the thing about fixed update is the fixed update runs at a steady amount of time. So you'd think that we would be able to use that time and not care about the sample rate. But the thing is that nothing assures me that the samples are going to be aligned with this physics time. So I'm going to check just for safety the samples every time. So first of all, what we go to this audio source, right? We go to this audio source. And in it, we are going to every single frame check for the... No, hold on. First of all, there's a variable here that I've forgotten to deal with, and that is that we need to fetch the current sample rate of the track that we're playing. Now, since all the tracks are going to be coming from the same source, I think that it's very likely that they will all be the same. However, for the sake of safety, I'm just gonna check it every time we switch to another track. So, public, not public, what am I thinking of? Private, it's a private variable, we don't want to fiddle with. Private int, because the sample rates are always just a whole number. Sample rate. This is in hertz. So, the sample rate. Where do we load the thing? Well, on awake we have to check, right? And then we also have to check on scene loaded. So if you get this far, then that means that the game object hasn't been destroyed. So then we can check the sample rate. So what we want to do is grab the audio source component, and we want in this audio source component check its audio clip. So we want to check the clip that we're currently playing, and within that clip we want to check the samples. No, that's the length. We want the frequency. Sample frequency of the clip in hertz frequency. Let's make this public for now, but we're gonna want to private it later public so that I can check it. And then sample rate is going to be equal that variable. Sample rate equals that. So let's first of all just absolutely check that that is giving me the number that I expect. What is the number that I expect? The number that I expect is this one right here, 48,000 hertz. Or is it 480? No, it's 48,000. Okay, that's the number that I expect to give me. So what I want is this number to turn to 48,000 as soon as I start the game. Excellent. Okay, that works good then. So that's giving me the number that I want. Then let's make this private now that we know that it's correct. Private. Now, I want to have this also should change whenever we load a new track. So in here, you do this again. You change the clip, you change the time to 0. Now you are going to give me the audio source again, the frequency again. So now whenever I change to another scene and it loads another music track, it's going to correctly give me, always be updating the sample rate whenever that happens. So what do I want to happen after? After I want I want to also have the BPM stored. So we are going to have private int no, not int. We're going to have it as a float. It's the BPM. And the BPM is going to similarly be established here. So BPM equals right, but the issue is that right, but the issue is that this doesn't know which scene we're on right now, does it? So actually, hold on one thing. Does the beginning of the execution count as loading a scene? Because if so, then this sample rate is going to be automatically updated here and it doesn't matter. Right? I have an impression that it probably doesn't, but it might. I don't know. Right, it's private. I didn't make it public, so I can't see the number. Public. No, it doesn't do that. So, that's an issue. Okay. Right, so how am I going to get the BPM when we haven't done any of this? Well, the obvious thing would be to make sure that we do this. The problem is that we're gonna have to give these two variables, right, aren't we? Actually, do you even use this mode? You don't, so I don't need to pass this. It can just be like scene, and a scene is just some text, right? No, a scene is an actual scene. Does this break? Yeah, it does. Okay. Should have known that. That's the reason why I put that there. Okay. So what I can do then is make this trigger another thing and have that thing work only off the string that is the name of the current scene. Then I can get that scene and run this without having to run this. Might be a bit of bloat, but if it works, right? So then we're gonna need to have another function. It's going to be called, it's going to be a void type, and it's going to be switch music. Switch music, and it's going to take a string, and that is the scene name. And this does basically the same as we were already doing right here. All of this. And so now, instead of scene point name, we have scene name, a string that has been passed. And that should be as much as we need. Right, scene, 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 scene. Yeah, this is scenes, which is a different thing. Scenes is the one up here, so that's fine. Those are not the same variable. So now, on scene loaded, what it's going to do is going to call switch music. It's going to call it with scene point name as a variable, and that's fine. And now what that means is that I can call this without necessarily having a load scene mode. Which means that I can call it just on its own myself, which means that I can call it here. Switch music. And then string scene name. Now, how do I get the scene name? That is... how do I get the current scene name? That would be nice to know. So Unity scripting API. How do I get the name of the current scene? How do I get the name of the current scene? Unity scripting. Scene management, scene name. Returns the name of the scene that is currently active in the game or app. Okay, that's easy. So scene management. Yeah, so just scene point name. And that should do it. And that means that then... Right. I keep forgetting that that shorthand doesn't work. An object reference is required for non-static field method property scene point name. What are you talking about? Did I close the browser again? Fucking stupid slut. Yeah, there you go. Okay, so this is what I want. So scene point name. Scene point name returns a runtime read-only string value. The name. Oh, returns. Wait, returns? What the fuck? Scene point name. No, it should be fine. Remember the scene point name? Scene manager get active scene. Scene point name returns a runtime read-only string value. The name limits to 244 characters. The scene name defaults to scene. The user changes the name during game creation. The following script example changes the scene depending on GUI button clicks at the name of the scene. To make this example work, the script will get an object related to scene 1 and scene 2. Touch the games. In my first scene field and my second field into the names of the scenes you would like to switch between scene 1 and scene 2. These are the scene names. Make sure to set them in the inspector window of my first scene, my second scene. Private, next one, load, next scene, false, rect, and with. On awake, scene magic, get active, C. Which version of Unity am I on? 2021, for fuck's sake. Of course that doesn't work then. Yeah, this is an older version. 2021.3, please. No, it's the same. Why doesn't it work then? There's 39, 939. Yeah, you're saying that switch music, scene point name. You're saying that this is not working. But this should return me the currently active scene. Unless this is just a scene type. And it's not actually like a global library that I can access. The name of the scene that is currently active in the game or app. That's very misleading though. So, hold on. Scene 1, scene 2. Get active input. Turn the current active scene in order to get the current scene name. So, what is the difference between the currently active scene and the name of the scene that is currently active in the game or app? That seems weird. Like, why would each individual scene type thing hold the name of the currently active scene when the scene manager already does that? That seems weird. That seems like that's just badly written. Scene, whatever. Scene manager point get active scene. Get active scene. Then on that scene, get the name. That's all we care about. Right, so the question then is going to be, will this work? It should. Yeah, the thing starts playing, I get the 48,000 hertz. Okay, that's good. So now I can rely on this thing to give me the sample rate and all that stuff. So then, that means that I can also find the BPM of the thing as I load it, because the BPM is only stored in this library of musics that goes with each scene. So then we can be like BPM equals scenes, the one that we're gonna load, so scenes I point BPM. That's the name of the thing, right? Is BPM, or is it uppercase BPM? It's uppercase. Okay. I wish it wasn't, but it is. There we go. And then we're going to make this public just to be sure that this is working. Right, so the meme here is that I haven't set... One second. Right, that I haven't set this number manually, but it should work regardless. Also, why do you say... Oh no, the headers are per... Ah, that's a pain in the ass. Okay, whatever. It should switch to 220. Great. Okay, so now we know the variable. We also should know in here the first beat. So public int first beat. And then whenever we change the thing, the first beat should be equal to the first beat that corresponds to that particular song. So the first beat equals this variable. So scenes, the current scene, point first beat. And this one I'm not going to check because like I'm pretty sure that this is going to work regardless because it's exactly the same as the other two. Right. So what we want now is to calculate or to keep track of the beats and be able to show when each of them happens, and whenever one of them happens, throw an event at, right? So like in this case, for example, we have this cube. Oh, I took out those. Okay, let's say that we want this cube and we wanted to move to the position similarly like it did last time, but it wasn't doing it on beat. Now we want to do it. We want it to happen on beat. So 200. We have here 202. Right, so it should switch between up and down. And it should do it on the beat, and it should do it on the beat regardless of when we replay or rewind the thing. So we're going to give you an empty game object that is going to be the manipulator. And it's going to be, this manipulator is going to tell... No, never mind, this is not going to be like this. No, this is not going to be like this. Right, because that's independent of this, and we want it to happen from here. So we want this script to be sending messages to this thing to update on beat when that happens. So, but first of all, we need to calculate when each beat is actually happening. Oh yeah, that wasn't what we wanted the manipulator for. Yeah, we wanted the manipulator, but for another motive. Yeah, we wanted it because we want this to, yeah, we want this to move us to a particular sample. Why? Because then moving this to a sample should move the beat, right? Because I'm doing it without a care for where the beat actually is. And so what that means is that what that means is that if the cube manages to remain on beat regardless of me just kind of switching this shit at random, then that means that we're properly keeping track of where all the beats are in the music track. So wouldn't that be amazing? So this is going to be a lot of maths. So first of all, we have our audio source. We have our sample rate, we have our everything. So first of all, we want to get from the audio source what our current sample is. So int current sample is going to be equal to the audio sources. And let's go back to here and check what those are. Audio sources, pitch, spatialized time, time in samples. The current sample that we are about to play or playing, you know, whatever. Let's go 48,000 of them per second, so it doesn't matter which one it is, right? Then what we want to do. So first of all, we're going to need to keep track of from the first sample. So we are going to need to calculate what the interval in samples between beats is. This needs to be calculated only when we switch the music tracks, because that's going to remain the same and is only dependent on the sample that the first beat lands in and the BPM, right? So first of all, we need to translate. BPM is beats per. Actually, I'm going to need to draw this out, right? So first of all, we have, where is paint? So first of all, BPM is beats divided by minutes, right? That is our starting point. This is the number that we're starting from. So we want to get from here to we want to get from here to what? We want to get from here to the amount of samples in between two beats, or in other words, the samples per beat, right? So we want to get from here to, that's already here, so this is our endpoint. Samples per beats, right? So how will we achieve that? First of all, minutes and samples are both measures of time, right? So we want to go from minutes to samples. Now, we know that the sample rate is 48,000. Actually, it doesn't matter what the specific number is, but we know that the sample rate is measured in hertz. So the first thing that we should do is actually find out what hertz are as a physical unit, right? So hertz are, yes, the unit. Thanks, Wikipedia. Wikipedia says that hertz is the unit of frequency in the International System of Units, equivalent to one event, in this case, one sample, per second. So hertz is samples per second. So If we want to convert from beats per minute to samples per beat, we have to convert this minutes to seconds. That means that we're going to have to multiply this by minutes divided by seconds. This will make these two cancel out, right? So then we'll have beats per second at the end. Now, how many minutes in 1 second? Well, a 60th of a minute, isn't it? So that is 1 divided by 60. So bits per minute divided by 60 is going to give me beats per second. Then we have beats per second. I want to multiply. I want to get the reciprocal of this. So I want to grab all of this and divide it by 1. Divided by 1. So that then, no, not divided by 1. What am I thinking of? Take all of this and divide 1 by all of this. So 1 divided by whatever number this gives me. Because that is going to give me, instead of beats per seconds, it's going to flip it. So it's going to be seconds per beats. See how we're getting closer? So then this I multiply by this sample rate, because this is going to be seconds times samples divided by beats times seconds. The seconds cancel out with the seconds, and then I have samples per beat. So then this is going to be multiplied by this. Right. So with that in mind, that is the math that should give us the amount. Let's rethink why we want this number. The amount of samples that is in between 2 beats, which is to say how much this number that we get from the current audio sample has to be different to get the thing. Now the thing is that this is not going to change, so we can do this only when we switch the music track. So let's actually have a variable for this. This is a private variable because it shouldn't be changed from the inspector. It should be changed in functions of the others that we have changed. And this is the samples per beat. Samples per beat. Samples per beat. Let's call it the sample interval. This is in samples per beat. This is going to be a useful number, right? So then, let's return to this and see how we calculate that. We have the BPM. We take this sample interval. Now, sample interval equals beats per minute divided by 60. That is here. All of that, 1 divided by all of that gives us the reciprocal, so the seconds per beat. 1 divided by all of this gives us the seconds per beat. And then multiply that by the sample rate. Multiply the result of this by the sample rate. And we get the number of samples per beat. Now this is probably something that can be simplified a little bit. Multiply both sides, the upper and the lower, by sample rate, and you get sample rate divided by BPM. No, just that, right, doesn't it? BPM divided by 60. Right? Am I right? Yeah, because this is a fraction, so multiply the 1, and then the bottom is just 1, so BPM divided by 60 times 1 is just BPM divided by 60. So then we have that. Then we can... instead of dividing the thing by 60, we could just multiply this by 60. I think those are equivalent. Sample rate times 60 divided by BPM. So let's check again what that gives us. So the sample rate is in hertz, that is samples per second. This is how we check if a formula is actually correct, is by checking if it gives us the units that it should. So since the calculation is the same, it should give us samples per beat. So the sample rate is in hertz, that is samples per second. So I can just make this big. That is samples per second. So we have samples per second. Samples per second divided by 60. Now, what is 60 in this case? It's seconds per minute. So, yeah, times seconds per minute. And that is all divided by BPM. So that is divided by beats per minute. But when you divide by a fraction, that's the same as multiplying by the reciprocal. So it is same as multiplying by beats. I wrote bits. Beats per minute. So then, minutes cancels out, seconds cancels out, and we get samples per beat, which is samples per beat. So that means that this is probably correct. Ain't math fun? Okay, so given that we have that then, now we have the interval in samples between one beat and the other, which means that we can calculate where every single beat is just by having these two numbers. So if the first beat is at, say, sample 27,000, then, and the sample interval is 100 samples per each beat, then we know that all the beats are going to land at 27,000, 27,100, 27,200, 27,300, and basically every single 100 after that. Right? So having that, we can check. So now we can every frame be checking if we're surpassing one of those thresholds, right? One of those milestones. And if we are, then a beat has happened and you have to execute the things that you want to execute, which are given by a Unity event, which we haven't done yet, so that much is easy. We just need to make a Unity event type thing and put it here. So Unity event when it's on beat, do whatever. So we have to make sure to execute this every time we detect a beat. So that means that we need to keep in mind what the last beat that we saw was, right? Because that's how we know if we have crossed over a beat. But the problem is that if the sample rate moves, then that's going to execute an erroneous beat, isn't it? Do we care, actually? I think we probably don't. Because we're not going to be fast forwarding or backtracking the track all that much. And when we do, one extra beat is not going to break things anyway. So we probably don't care much about that. So yeah, we're going to need a variable that is the previous frame sample. Private int. Previous frame sample. So yeah. Oh, this is where the math is going to get a bit complicated, actually, because we're going to need to find out the lowest beat sample that is above the the previous frame sample and then check if we've crossed it. So first of all, previous frame sample here is going to have to be equal to 0. So previous frame sample is going to be equal to 0. That much is just easy. So then current sample, we have a current sample int. So now what we have to do is check the next beat sample from the previous frame sample that we have detected here. So int next beat sample is going to be equal to something we don't know yet. Now, if a previous frame sample, yeah, the sample that we were at in the previous frame. So if on the previous frame we were at a point before the first beat, then the next big sample is going to be the first beat, obviously. Previous frame sample is below the first beat. Then the next beat sample is going to be equal to the first beat. Otherwise, we're going to need to calculate. So if the previous beat sample, frame sample, is the sample in the previous frame is after the first beat, then the next beat is going to be what? Well, we can get every beat by taking the first beat and added to it multiples of the sample interval, the interval in samples between beats. So first beat times sample interval plus 1 plus 2 plus 3 plus whatever. 3 times sample interval, right? So how do we find exactly how many sample intervals we need to add before to get to the one right before the previous frame sample? Or rather, to get to the one right after. Well, what is going on here, right, is that we have this thing that is giving us a bunch of different points on the line, and we're... Oh, this is a toughie. Okay, so because this is series, and this is always like the lazy part of math. This is a series. This is a sum. So how would I do this? It would have to be... It would have to be... Right, okay, let's write a couple of things down. First of all, every single sample that lands on a beat or close enough to it is going to be able to be expressed in the form of first beat plus I times sample interval, where I is any natural number, right? Let's comment that so that I don't actually mistake it for code later on. Where I is the number is any natural number above 0. I forget what those are called, but any integer above 0, right? Any positive integer. So actually, it can be 0 too. So it's 0 is the first beat itself. 1 is the first beat plus the interval, so the first beat after the second beat, and then when I is 2, it's the third beat, etc. Right? So now what I could do is run I until this gives me, but that's an iterative function. There's gotta be a mathematical way to find out what number I is. So, what would that way be? It would have to be doing the operations in reverse. So if the current beat, right? So if the current sample, right? So if the previous frame sample, right? If we take this previous frame sample, the sample that we were at in the previous frame, and to it subtract the first beat, right? Then we will have the previous frame sample relative to the first beat. So how many samples since the first beat have happened? If we take that and divide it by the sample interval, then what we're going to have is how many beats have happened since that. Now here we have a problem, is that I need to check whether some of these are ints or whether some of these are floats. First beat is an int. Sample interval, though, is a float. So that means that we have to convert this to a float so that this division is actually able to make sense. Previous frame sample is an int. So then we're going to have this to make this into a float so that all the math works out. So this is going to give me a number that is a decimal of how many beats have happened, or rather, how many beats the sample that we were at on the previous frame is on. So then to that number, and also these are go like this. So then to that number, we add 1, and that is, no, actually, first of all, we have to floor this number, because this number might be a decimal, so we could be like 1.5, which means that we're halfway between the first and the second beat. I don't want that. I just want the next beat. So then we can have, we want to take that number and floor it. Math point floor. I'm pretty sure that's the name of the function. Unity floor function. Unity floor function. Math floor function. Math, yeah, it's math, but with an uppercase M. So that'll give us the floor. So it's gonna give us, if we're halfway between the second and the third beat, we're going to have the second beat. Actually, what I want is the ceiling, because then I don't have to add 1 to it. Math point ceiling. It's just seal. Yes, okay, seal. So then that'll give us the number of the next beat. It'll give us beat 5, beat 6, beat whatever, right? This is going to be an integer. Then we want to check what sample that beat lands on. Let's just make a second line. So what sample does beat I land on? So it's this times the interval between samples plus the first beat. So we can just grab all this. No, let's actually write it out so that we can actually do things that make sense. So float next beat number equals next beat by number equals all this. Then we want to catch the next beat sample. So the sample that this next beat lands on is this formula. So it's the first beat plus I, which is the number of the next beat number, times the sample interval. Sample interval. So we have the sample that the next beat landed on. So now we have to check if our previous beat is smaller than the next beat sample, or no, if our next beat is larger than that next beat sample, then that means that we have crossed from before to after, right? So if the current sample is larger or equal than the next beat sample, if it's equal, then that means that we're right on the beat, right? Next beat sample, then a beat has happened, and then we have to call this event. So on beat, does it have any functions subscribed to it? If so, invoke them. Otherwise, just do nothing, right? And that should make it so that I can play and pause and play and pause and just do things to this background music. And it'll always be correctly keeping track of the beat at the cost of having to run these calculations every frame, which honestly shouldn't be a big deal. Did you save? You didn't compile anything, so that was a bit scary. There you go, now you're compiling. Right, if this works, I'm gonna be done for the night. The type or namespace Unity event could not be found, right? Because I didn't include it. I didn't declare that we're using it. We're using Unity engine point events, please. Thank you. Cannot implicitly convert type float to int. An explicit conversion exists. I'm missing a cast. Where? 6130. Okay, 61. 61, where's right, so next sample is an int. Here's first beat is an int. Next beat number is a float though, so I want to make this an int, and the sample interval is, this is depends to give me an off by 1 error. No, actually, I want to multiply them as floats and then only convert it to an int when I do this. Like this. Name sample rate does not exist. Okay, so I misspelled something. 84 where? 84 sample. Yeah, because it's sample rate with an uppercase R. Okay, there we go. Now we compile. Let's save the scene. Okay, so what we should get now is let's turn this off. So what we should get now is this event should fire up anytime a beat happens. So that means that I can give it to this cube 6. I can tell it, hey, I want you to do this function on this cube 6. I want you to move it. And I want you to move it whenever a beat happens. And the fact that the beats are calculated using the sample rate means that if I were to pause this thing, this audio source, it should be able to tell me, it should be able to also pause the execution of those beat events. So that means that this is probably happening every frame. That is definitely not what I want. What if I pause it? Well, at the very least, it listens when it is paused. And then if I tell you to play, there is a way to tell you to play from here, I'm pretty sure. Can you hear the alarm, by the way, in the background? There you go. Okay, if I tell you to play, you start moving again. Okay, so we are listening to the sample rates, but our calculations are probably a bit wrong. That makes sense. So, what are the numbers that we are seeing? I want to make all of these variables public so that I can see what numbers we're working with. So, public. Right, so all these numbers should be changing to something that makes kind of sense, right? So the previous frame sample is not changing, which makes sense because I forgot to do that. So the previous frame sample is never set, it's always 0, so the next so any frame is always going to be against that. So the previous frame sample, yeah, at the end of all these calculations, the previous frame sample is equal to the current sample. So that way we get to hang up to that sample for the next frame and use that in our calculations, because we need the sample that we're on right now and the sample that we were on at the previous frame. So they basically just piggyback off of each other. That should actually make it work. Okay, it's not exactly on time, there is some delay to think about, but I feel like that I can chalk down to being, screen visual offset. I can chalk that down to visual offset rather than to it having the wrong samples. If nothing else, if it's off by any amount, it's going to be off by the same amount always. And it is. So if I take this manipulator and turn it on, it is going to push me to a different place in the audio source. And this thing should stop moving so regularly because it should be trying to match itself to that new positioning of the BPM. Yeah, you can see it twitch a little bit, and that is because it's lining itself up. Yeah. When 2 beats happen very quick, it just moves very quick as well. Okay, so that's good. That means that this works. This is working beautifully, actually. So then, this manager, if we pause this music, by just okay, so when I take away the audio source, it just freaks out, right? And that probably shouldn't happen, but that's probably just because I'm turning off the audio source and it doesn't know what to do. If I pause the reproduction of this thing, it should work, right? So let's say that instead of moving the time samples to this, I'm going to tell it to pause itself. You should pause yourself now. Your play button serves zero purpose. You should end it. Okay, stupid. Audio source. Where's the pause method? Pause. It's just called pause. Okay, audio source. Pause. Like this. Right? So this then. So if I pause the thing, okay, give me the controller so that I can look at this without it. Okay, right here. You can see it moving, right? If I grab this manipulator and when I turn it on, it should make the thing pause. It pauses. Right, it doesn't then continue because I had it set to only pause. But the fact that it pauses correctly means that I can absolutely stop every execution on beat purely by doing all this. Oh, fuck, that was fucking... That works amazing. I'm surprised that I got it in like pretty much the first try. To be fair, I did spend like half an hour thinking about it, but still, it's pretty good. Okay, I'm gonna leave off on that success. That feels pretty good. And that means that I'm gone. Thanks for stopping by. I assume that you're Steve. Hey, Steve. The stream is ending. Bye bye. Boo boo ba ba. We're leaving. We're leaving. Leave. Please leave. Goodbye.